Hello, everyone. Welcome to yet another Buddy webinar. Today, we are going to talk about something about which, I'll be honest, I didn't have a clue before this webinar. We're going to talk why lack of SRAs, its site reliability engineering kills your business. With me, I have a true specialist in this matter, Philip Tepper. Philip, tell us a few words about yourself.
Hey, Magic. Thanks for having me. So I'm Filip. I am in Warsaw, in Poland. I am a senior engineering manager for the SRE team at Happen. My background is mostly software engineering. That's where I kind of started. Then I dived into cloud and infrastructure management, and right now, finally, I'm in this realm of SRE. But in general, my responsibilities have always been kind of blurry. So I'm trying not to put a kind of definite label on my career so far.
And my name is Maciek Palmowski. I work here at Buddy as a WordPress ambassador. Before we start, first of all, today we'll learn about a few things. First of all, what SRI is, why and when you should invest in it, or maybe not, and what are the consequences or not having it, or of not having such a department in your company. Also, if you like what we are doing, remember to press the subscribe button on YouTube. And if you have any questions regarding our today's webinar, just ask them in the comment section on YouTube, LinkedIn, or Facebook. Okay, so I think that's all. And Philip, so yeah, let's start with what is this site reliability engineering? What does such a person do?
I think it's $1 million question, really, because you can ask different people about what SRE is, and you're going to get totally different answers. First of all, this term, site reliability engineering, has been coined at Google, and I would say that pretty much every company, every organization that mentions SRE is kind of looking up to this idea that Google had for SRE. But then again, each implementation is very different. There's only one Google, and there's a lot of other companies that do things differently. You can call SRE kind of an implementation of the DevOps approach, meaning that it's a culture of fostering collaboration between software engineers and system operators. You can also call it a software engineering approach to operations. For me personally, but please take it with a grain of salt, this is just kind of how I see it. My definition of it is it's a set of practices, principles, ways of working that contribute to highly scalable and reliable software. It's about empowering engineers to own the reliability, availability of their systems, to let them understand what is the performance of their applications, to help them monitor their applications, to have a really good incident response process, because this is also a very important aspect of this, and essentially build great tools for engineers to make sure that they can run their applications. Of course, here we kind of diving a little bit into the platform side, but like I said, this is still a very vague definition of what SRE is. A huge part of the job is also working with automation and reducing toil for the most common tasks. But of course, there's always this temptation to automate everything. I definitely err on the side of being reasonable with the time spent versus time saved. So that's another aspect of it. A lot of SREs are also involved in system design and architecture process. So this is kind of the area that we contribute to as well. Something that is a little bit more ambiguous for me is how SREs contribute to the CI/CD process, because many companies expect SREs to do that. Many companies have a separate department to handle CI/CD. So again, this depends on the organization, and there's a lot of cool stuff happening in this area. For example, chaos engineering that started at Netflix, where you just essentially randomly break down your application by, for example, shutting down random servers or injecting network latency into your application. And essentially, you learn from that. It's something you do on purpose, and it's something that tests the resiliency of your application. But then again, I could probably go on for hours and hours just talking about what SRE is. But essentially, I think that it boils down to having a certain way of working with infrastructure, with automation, and providing reliability to systems.
So we can say that such an engineer has to know really a lot about a very wide range of topics, right? Because you already mentioned uh, development, uh, response to any problems, uh, system architecture, and it also depends on, as you mentioned, depends on the company at which you work at, CI/CD, and many other things. So, but in your case, okay, you start your day at work, and how does your typical day looks like?
Oh, I start on Slack like everybody these days. But in all seriousness, I think it's of course the technical skills are important, but it's also about the culture. So it's not only the skills, certain skills that are necessary. It's also about um, how you foster certain interactions in the company, how you foster certain practices to become more permanent. I would say that everyday life in SRE's life, every day in SRE's life is pretty much the same as every other software engineer, except we focus on different areas, right? So we have essentially all the software engineering work, except it is focused mostly around infrastructure, mostly focused around reliability and things like that. So it's not really that different. Of course, a lot of SREs are expected to be part of the incident response process, but then again, it feels to me, based on some conversations I had, that more and more companies actually put their engineers, software engineers, on call as well. So again, this is very kind of a blurry topic here. On the other side, if you think about incident response, it's the SRE culture that essentially brought a lot of practices into this area, like, for example, blameless debriefs, how to learn from that, the chaos engineering part I mentioned. So I would say SRE's life is just slightly different software engineers' life at this point.
You mentioned this term blameless debrief. Could you say a bit more about this? Because this sounds really interesting.
So I think it's the essential part of the SRE culture. Whenever there's an incident, you are expected to get to the bottom of what happened and mostly why it happened. And you're interested not in the who, but you're interested in what has happened, why it had happened, and then again, how we can prevent this from happening again. So essentially, you run through the incident, you gather all the information that you gathered to resolve the incident, and then you learn from it, right? You apply some immediate fixes that you need to apply in order to restore the service. But then again, important part of that culture should be that you make room in your software development process to address the issues that caused a certain outage, right? Whether it was something on the infrastructure side, whether it was wrong permissions, whether it was a bug in the application that caused, I don't know, increased network latency. You have to make sure that you learn from these experiences, and you make room for that in the software development process.
Okay, so and you also mentioned here that the who was responsible is less important, or it's even not important at all. So I see that it's kind of similar when we also talk about code review, that the very important part about code review is, first of all, not to take it personally. And when we write code review, It's also very much about emotions because our first reaction to such a review is we try to defend it. We try to defend it personally, and it's more than that. It's not about us. It's just about the code. And here, as I understand, this is the same, but it's not just about the code. It's much wider. I would even say that it sounds a bit like being a private detective in the company, but trying to find, as you mentioned, we gather all the clues from all the departments, and
Well, I would say yes. I would say that my immediate thinking when I think about it is that I can give you an example. Let's say someone removed a critical part of infrastructure,
Mhm.
and that caused, for example, downtime. For me, it's extremely unimportant who did it. What is important is that some action caused the downtime. And my question here right now would be number one question is why was it allowed to happen, right? Why a person who was in this department who had a certain set of permissions, it doesn't matter what the name of the person was, but why was a person who should not be having certain permissions had these permissions granted, right? So this is a gap in the process. This is not a human error. I mean,
Mhm.
it was a human error, but it should not be treated as one. We should design our systems in a way that should prevent these kind of actions, right? So this is again a learning experience. Okay, we did not foresee that certain thing might happen. It was the system mistake, and we are here to correct that system mistake and not to blame anyone in particular. What I learned from one of my earliest bosses was that this is actually something that is extremely valuable. I deleted a production database on my first day at work, and I was expecting the worst. Really, I was expecting to be fired, but the CEO of the company came over and he said, "Thanks for discovering this extremely important bug to us." He said, "We're gonna be fine. We have all the backups. We've lost a couple of messages from our instance, and that's it." And I think that this is the approach we should take. This is a learning experience. This is something that helps us improve our systems, helps us understand our systems better, and make them more resilient. So it's the greatest opportunity for us to learn and understand how we can do things better.
Yeah, because one of the most important part in your case was not the fact that you deleted the database, because yeah, it happens. I mean, this engineer at GitLab probably still thinks about the day that he had. But the fact that you, as a first day engineer at your workplace, had the possibility to do so. It
Exactly. It's
shouldn't happen. It shouldn't happen. Only a small group of people should have access um, to such a dangerous operation, because
absolutely. I would even argue that today, with all the fantastic tooling, especially related to infrastructure, there should be actually very few people, if any, with such a power. You can do really remarkable things with all the tooling that you have for infrastructure as code, all the automation that you have already available. So, like, if you want to go down that path, then yes, I think that you should be very critical about handing out these superpowers. And there are certainly different ways of doing this now, and that gives you a lot of confidence in what you're doing in general.
Mhm. Uh, Also, the thing that you mentioned, and this is also the thing that I really like to hear, because it happens more and more often with different approaches, is the fact that SRA is a culture. We also say about this about DevOps and about many things. We also say about accessibility, that it's more than just accessibility. It's the way that we all think about this. So what is the hardest part to convince other people that this SRA way of doing things is worth it? And what are the biggest problems in trying to convince some people?
I have to say I've been mostly fortunate enough to not have to make a very strong case, because I think it's really a very reasonable approach to software development life cycle in general, because in the very end it actually serves a very important business case. So you have your software more resilient, more reliable, customers are happier, you understand the issues that you're facing much better, so you can have a much better communication with your customers. You can be ahead of your customers, really, if you have good observability, good monitoring of your systems. Then you are ahead of your customers. You don't have to wait for your customer to report a bug or downtime to you. You are ahead of them, and you can react faster, essentially shortening this cycle. So I would say I'm only seeing benefits from this perspective. Obviously, that means that there's more work essentially for everyone, right? But then again, you have SRE teams that are, to a certain degree, teams that help build tooling for maintaining this culture in a way. Looking from software developer perspective, if it's easy for me to add observability to my application, then I'm happily going to do it, because I can clearly see the benefits of that, right? I can detect performance issues. I can detect latency. I can detect just about any issue with my application and very carefully monitor its health and be aware of its health and be able to react faster. But I often find that, yes, it is not as easy as it might seem, mostly because tooling right now is kind of all over the place, right? There are certain, I would say, business leaders, if you think about this area, but there's still a lot on SRE teams that has to be essentially enabled, built, glued together, so that engineers have a good experience, because really engineers are our customers and we want to make our customers happy as well. If we provide tooling that is difficult to use, has no documentation, doesn't really bring the expected value, then it's really hard to justify this case. But then again, if you have good tooling, if you have good culture, good documentation, then it at some point it becomes really obvious to everyone. Yeah, like I've released this application to production, but I have no visibility into how it's performing. I don't have that confidence that the tooling, that the observability gives me. And yeah, I would really like to have that, right? I feel more confident when I understand what is actually happening with my systems.
Okay, yeah, I understand. And yeah, you mentioned tooling. So this is kind of a natural next questions. Are and you mentioned that there are some tools for SRA. So what are they? Especially this is kind of interesting when you think how wide of a topic it is. So
It is. It is very wide. So on a daily basis, we really use a lot of tools, and I would say that my kind of favorite area is observability, and there's a lot of really great tooling that I would say is quite acceptable as industry standard. Uh, if you're into Kubernetes stacks, then pretty much everyone is working with the Prometheus stack. There's Datadog, who's doing remarkable things on the market. There's the Elastic Logstash Kibana stack for metrics and for observability in general. So this is the tooling that a lot of companies or a lot of organizations are using today. There's a lot of great tooling for incident management. So essentially to provide certain guidelines, certain way of doing incident response process. There's a lot of tooling for essentially ruining your night, like PagerDuty, which calls you in the middle of an incident to kind of put you in front of your computer and start solving the problem. But this is like only one aspect of it. Especially my team, we deal a lot of with a lot of infrastructure. So we use a lot of infrastructure as code tooling, configuration management, infrastructure management, whatever you want to call it. So there's Terraform, there's things like Ansible, all these, I would say, old school tooling in this realm. But then again, they have proved to be really reliable and essentially invaluable at a certain size of your organization, because otherwise it's just Managing infrastructure manually, that's not something you want to do, like probably at all. Obviously, a lot of I would say common tools, like for example, everybody's using Docker. A lot of companies are moving or already are well into Kubernetes. Very important part is that we also use a lot of CI/CD tooling, like for example, Buddy, of course, because that gives us a lot of confidence into how we, for example, work with our infra as code. Right? We essentially treat infrastructure as code as any other software, so that really ties well into the whole software development process. And of course, if you're managing infrastructure and working with system design, that means you're evaluating a lot of storage engines. You're evaluating all sorts of network appliances that you can run in the cloud or in data centers. So yeah, essentially you have fun with a lot of tools, really.
Yeah, the list was very, very long and from so many topics. So yeah, but I'm sure that working in SRA, it's pure fun if you like to play around with different tools.
Um,
Until some point. Until some point.
I mean, I would say that incident response, unfortunately, is an important part of the job, and that is always tricky. And that's definitely, I would say, like this is a really important topic because it's not only about how you work with tech, but it's also how it influences your team. It's a stressful process to be involved in the incident response. It is a process that puts strains on your family life if you're on call of hours. So there are different aspects of it. But then again, being responsible for certain areas makes you think essentially twice before you commit to something that might wake you up in the middle of the night. Personally, I very much enjoy boring technology, meaning technology that has been proven, technology that is exactly boring, meaning there's a lot of people who understand how it works. It's fairly reliable. It is something that you have a lot of confidence in. So yeah, different aspects of this very topic.
And probably some people would say that you are talking about many things that would be described as legacy software, but those legacy software in many cases just work in a very boring way without any accidents and everything. So,
Well,
uh,
in distributed systems, you cannot have incident-free environment, but yes, in general, yes.
yeah. And tell me, who needs SRA? Does every company should think about it, or maybe not having the whole department? Because you mentioned it's a culture. It's a culture. It's also a culture like DevOps, a culture like, let's be honest, CI/CD, because CI/CD is also a way of dealing with software. It's not only about writing tests and everything. It's also a bit about the thing that you mentioned that uh, I rather think twice and add some additional testing rather to be awake at night to fix something on production.
Well, since I see this mostly as a culture, I would say I would answer with my favorite answer is it depends. If you have a small, nimble team that already knows their way around certain aspects of reliability, then I would say you're probably fine and you probably don't need a separate team. If you have a team that lacks these skills, try embedding an SRE into this team. Make SRE and the whole concept around SRE part of the process inside your team. Maybe you want to have a separate team. Maybe you know that there's so much need for building stuff that it will keep a separate team occupied, and on top of that, add some embedded SRE. So I would say there is really no good answer, and this very much depends on your organization. But uh, I remember when I started kind of building the first infrastructure team a couple of years ago. I started doing that because I noticed gaps in how we essentially at that time monitor our infrastructure. So that was kind of a common sense approach. Okay, I wasn't aware that it's called SRE at the time, But apparently, what I did was I started building this SRE culture where we started understanding our application better. We got more insights into how we're performing. And yeah, we didn't call it that way. It was just a natural approach. So I think that it's more about fostering this culture and having understanding that this is something that every serious or not so serious even business needs, just because it gives you confidence in your process.
So you would say that it would be great that even the smallest company would learn about how SRE works and try to figure out how to figure at least some of its ideas into their stacks, either by providing the whole team, which probably when they are at the beginning of their journey is quite hard. That's why the better approach would be just use the methodology and start without the extra people because
Absolutely. There's a lot of great tools that have very low barrier of entry. You don't need to have a separate team to, I don't know, start monitoring your application or add an APM or anything. If if you have an early stage application, you're building an MVP, it's so easy to add it and then build on top of that, that it would be really a sin not to do it at this point, right? Obviously, at a certain level of development, you're going to expect more from this stack. You're going to have a more thorough process around how you're building observability. But at the same time, it is so easy to start. It's mostly free to start. So really, like it's a kind of gateway drug into having
Mhm.
this kind of setup and start building with this mindset.
Okay, yeah. So, uh, like with many different methodologies we have in IT, the same goes with CI/CD, the same goes with DevOps. It's really easy to start, and what's interesting, if you want, then getting started at the later stage will be much more difficult. And tell me, if you would, if I would think about starting a career as a site reliability engineer, what set of skills would I need?
That's a tricky question. I could answer that you need all
It
of them.
depends. It depends.
No, no, you
I
probably
hope.
need all of them. But then again, yes, this is also depending on the kind of organization that you have. But I would personally, what doesn't hurt is having experience in software engineering and or ops, obviously, because this is the area that kind of glues together both of these specialties. I think when building a team, it will be super important to actually have people with kind of both kinds of backgrounds. So that's one thing. Um, I think that people working in SRE need to be really good communicators and good team players. They should be able to foster collaboration, because it's not only about kind of hard technical skills, but it's also about the soft skills that they need to have in order to be efficient in this role. Obviously, you need to know the basics of how to deploy an application, how to use Kubernetes, things like Terraform. But then again, every company will have a very different set of tools that they're using. Mm, I would say that at a very high level, if you enjoy engineering work, software engineering work, and you have a knack for infrastructure, you're probably set. I would say that exploring AWS is a good starting point if you want to get around into this topic, because you will learn so much just by looking at different areas there. I know that it kind of goes into the area of infrastructure management and possibly platform, but then again, it's so difficult to kind of draw the line between these areas. So I would say the more you know, the better SRE you will be.
Hmm. Yeah, I understand. Yeah, I mean, it's kind of a consequence of that's what we mentioned before, that it's a very SRA in general is a very wide topic. So, um, yeah, so you have to know a bit about everything. And the thing that SRA is doing is reacting to different accidents. And tell me, in practice, maybe you would have some great example how a typical reaction to an accident looks like from the beginning. Some big accident happened, and what you do step by step. I
Um,
know it depends. It depends.
no, no, no. I was actually going to say that it's a fairly common process that's shared between companies that actually do have this kind of incident response, incident management process, right? So usually you have someone who is on call who is able to respond to an incident, whether that incident has been created manually by, for example, customer support team, or whether that incident has been created automatically from your monitoring, because essentially that's how incidents in a perfect organization should start. And then essentially you have someone who is on call, who is an incident commander. That's the kind of official title that is being used in this area. You would have a scribe who is taking notes. You would have responders who are actually diagnosing the problem. And then, yeah, you essentially dive in. You try to figure out what is actually happening. And I think that really great way of understanding that is actually having monitoring set not on the infrastructure, underlying infrastructure, but on the customer journeys, right? So if I understand how a product is broken for my customer, then I can start looking into that area. And it's a kind of all hands on deck situation. You try to find, or you know how to find in a great environment, people who are responsible for a certain area of the application, and essentially you bring them in to help you diagnose the problem. If it's an application problem, then obviously it requires a patch. If it's an infrastructure problem because, I don't know, database went down, then you have to figure out how to bring this back. So the immediate focus of the incident is restoring the service. That's number one priority, because your customers are waiting for your service to be back online. And then there's the whole debrief process that we've talked about, and essentially making sure that we learn from this process and we try to be never ever paged about it again. I think that that is a great outcome of every incident, is that it should happen in a perfect world only once, because then you find ways around preventing it from happening again. All in all, it's a super stressful situation, because you know that you're kind of trying to game the clock, and you know that the sooner you can do it, the better. But it's not always super obvious what exactly you need to do. Um, a lot of good practices can be employed to make it a little bit easier. If you have good automation around and your infrastructure and your application, and you have good monitoring available for that, uh, then you can essentially make the process as easy as possible. So, for example, what we try to do whenever you receive an alert, there's always something for you to look into. For example, a dashboard or a run book to follow, right? So that we try to follow essentially the most common cases and have them documented, so that it's easier for the person who is already in a lot of stress to actually take action. Uh, if that fails, then, well, it's going to be an interesting couple of minutes or hours in the worst case scenario. But essentially, it's a lot of debugging. It's a lot of trial and error. I would say that probably probably it's the most stressful piece of any engineer's work when you're working with software, with the web, is essentially you have to figure out what is happening. Sometimes it's not as easy as it might seem.
Yes, as a as a developer, I had the pleasure to be on. I mean, on you have a chance to hear a client yelling at you, and because he thinks that thanks to with ETL it will be a bit faster. Well, it's not. And on the other hand, you try to concentrate and do your job. And one thing, because with such an approach, I still understand that the first thing is to create a hotfix, a patch, and the next step is to make this patch, this hot fix, a proper fix with all the tests, with all the documentation and everything, right?
Yes, I would
Yeah.
say that's a fair assessment. Definitely. I mean, it's the alert, the on-call fatigue is real. It is a real problem. If you're being paged every day,
Mhm.
a couple of times a day for the same problem, that means you're going to have a problem not with your customers, but you might simply lose your team. You might lose the people who are working with you. And that's the worst thing that can happen, because there's only so much heat people can take. And I just want to briefly mention what you said. Like, an engineer should be absolute, or the whole response team should be absolutely shielded from the customers. They should be shielded from anyone who can interrupt this process and distract them from solving the issue. So if that was the case for you, then that was not a great incident response process, right?
No,
uh,
no, it wasn't. It wasn't. I'm sure.
So yeah, I think that the team should be given all the freedom they need to essentially solve the issue. Obviously, you have certain roles in the incident response process that essentially their goal is only to maintain this communication between the response team and, for example, the customer facing teams. So that is also an important part of the response process. But essentially, the people who are working, in the heat of the moment, they should be given all the tools, all the resources, or all the distraction free environments that they can get.
Yeah, I understand. And the last thing I wanted to talk, I mean, you mentioned it a bit because you described a bit that the SRA team can differ, especially when it comes to where they are put in the company. But yeah, I wanted to talk a bit more about the structure of such team, how they look like. Are those big teams, small teams? Where can we put them?
So there's a couple of different ways that have been actually pretty well documented. There's a book called Team Topologies that I can recommend. It's really one of the best books that I have read in a really long time, that are around the whole business of IT, software development, and team building. So I would say this is a very good resource, and it gives you a couple of different ideas how you might want to build out your SRE platform or infrastructure teams. There's also this little kind of addition, DevOps topologies, that shows you a couple of ways of doing that, as in embedding, having separate teams, having time fixed collaboration. So this very much depends on what you're trying to achieve and where your organization is in terms of, let's call it SRE maturity, right? There are as many good ways of doing it as bad ways of doing it. And I don't want to say it's trial and error, but you have to be very mindful about the goals that you have in mind for that particular team, and choose the right alignment in the company. My team actually moved from a separate, disconnected team into an embedded one. I feel like this, at our current stage, has given us a lot of value. There's definitely much better collaboration between engineering teams and SREs. There's dedicated people who know and understand the area they're working with. So I would say so far the embedded model has been quite good for my team. But again, your mileage may vary. I very much encourage to have a look at the team topologies, DevOps topologies, readings, and it's a really good material if you want to essentially start figuring out how to structure this inside your application. And of course, the Google SRE book, that's the Bible of every SRE. Well, it's a couple of years old now, really, and you should probably take some of these experiences with a grain of salt, especially today. But then again, it's a great starting point if you want to understand the area a bit better and start figuring out how to fit this into your organization.
Okay, so yeah, really, I've thank you so much because I learned a lot. Because, like I mentioned at the beginning, SRA wasn't something that I heard of before meeting you. This isn't some. I mean, the SRA isn't a topic that it's so popular. I mean, uh, CI/CD is having at some in some environments problem with popularity, but SRA is less popular. But I really like the approach. I really like the approach. I really like the way the way it can fix many things, because you also mentioned this the things about the teams, about how much pressure they can take, because accident response can be horrible. Can be horrible if we aren't shielded from the client, especially this yelling type. And in some cases, let's be honest, things happen, and having round after round of such a client, for some people it can be just too much. And yeah, this is a simple way to lose a administrator, a developer. It depends on the role, but and this is really interesting that SRA also uh, a bit, maybe it's not its main role, but it does. It also a bit takes care of the team, just by all the processes, by all the procedures. And also the moment that I ask you about the typical response when accident happened, you mentioned there is a process for that. So yeah, it's that. I mean, that's normal. There should be a process for everything in such a in such an approach. And also the blameless review. This is also interesting. It's a very interesting concept, and I think in some ways it also should be adopted in other branches of IT, or in some cases it already is. So, from what I see, we have one question: uh, when you should add an SRA team to your project.
I want to say start as soon as possible. Like I said before, I don't think you need a team to begin with. I think that having someone who can enable this culture, even just a single person, is already a huge win for the team and for your system in general. So I would say start as soon as possible. But then again, I realized that for many companies, building out separate infrastructure teams or SRE teams is an afterthought, right? And I completely understand this from a business perspective, because if you're building a product, your first thought is to figure out, okay, do we have customers for that? What is the market fit? Can we even succeed? Can we have the scale that justifies building teams that support the main process? So I would say start as soon as you can. You're not going to regret it, probably. But the reality of it is that a lot of companies think about these kind of support teams as an afterthought, which again is fair. This is a very fair business case. So a lot of the time when the SRE team comes in, or SRE person comes in, the first thing they do is they evaluate what they have around and try to find the areas of kind of immediate work that needs to happen in order to bring up a certain aspects of this culture to a certain level.
Okay, yeah, I think that answers the question. And before, I mean, during the webinar, we asked the question on our YouTube poll: are you familiar with SRA practices? And what's interesting is some people are. One third know at least some SRA practices. Um, that's great. I'm kind of surprised because, like I said, I thought that less people will be, but that's really great to hear. And I want to say that if you want to get notified about more of our webinars, join our meetup.com group called Buddy CI CD group. Also, don't forget to subscribe to our YouTube or maybe Twitter, Facebook, or LinkedIn. It's up to you. It's also a great place to get informed about all the upcoming webinars. And in 2 weeks, we will be having Christine Dangle, and we will talk how to automate tests with Cypress and TestRail, and of course with Buddy. So this should be a really interesting webinar. So Philip, thank you once again. It was. A very, very interesting webinar. I really learned a lot, and I think that I will be buying this book, Team Topology, because it really sounds interesting. Because I know how different team topologies can affect the way how we work, and also from my perspective, I also like to learn how do some people think about putting the design team, because this is also a very interesting topic. Probably not in this book, but still an interesting one. So, Philip, thanks you once again, and thank you everyone for being with us. Thank you, Moala and Lax. I see that you are with us every time. It's really great to have you here, and see you in 2 weeks. Bye, everyone.